Hello again, everyone. All right, so today, yesterday we talked about, we were reviewing for our new unit in stoichiometry. We talked about what stoichiometry is, and we talked about the importance of having balanced equations for stoichiometry. So, a couple more things you need to know before we really get into stoichiometry is, let's remember about this term right here, mole. Okay, so we talked about it before. It is a handy way of keeping track of the number of atoms or molecules. Okay, so yesterday we did this. And we talked about this balanced equation represents a chemical reaction. And we said that stoichiometry has to do with kind of predicting how much product you can make from a starting amount, or figuring out how much starting amount we need in order to get a desired amount of product. Okay, and we're going to use this as kind of this balanced equation as kind of our recipe. So maybe you wanted to make a certain amount of oxygen, not just 1 mole of oxygen. Maybe you wanted to make 25 moles of oxygen. Because you have this balanced equation, you can see the relationship of the reactants to the products. So a balanced equation tells you that relationship, but it's not a relationship of mass or how heavy it is or the volume. It's a relationship of the number of particles. Okay, so when we're talking about realistic amounts of particles, it's going to be very difficult to use really, really large numbers because, atoms and molecules are really small. So instead of using the actual number of particles, we're going to use groupings of particles. Remember the mole, and we saw a video where I represented the mole kind of like this. Okay, so you have a container, a grouping, or a package of something, and the amount of it is a mole, and we know that what that exact amount is, right? Let me finish writing this out. So a mole is a handy way of keeping track of the number of atoms or molecules that are involved in a chemical reaction. Okay, and what's important to remember about this is a mole is not talking about how heavy something is, so not how heavy, okay, but how many. Okay, that's what a mole tells you. Not how heavy, but how many. And this mole is important in stoichiometry. Okay, and we also know that it is 6.02 times 10 to the 23rd. So a mole, the number is a number, and if you have a mole of something, okay, so you can imagine you have this sack that has, it's full of whatever, basketballs, atoms of gold, whatever. If you have a mole of them, then you have this many of them. Okay, so think of it like a dozen. You know what? I'm not going to put that in there. Okay. All right, so the mole answers how many, not how heavy. Okay, the next thing we need to remember is, well, we need to distinguish, is mass. So mass is the unit in grams, is how heavy something is, right? So this is how heavy. When we talk about mass, we're talking about how heavy. And the unit is grams when we're using it for high school chemistry. Okay, and we need to know math, even though stoichiometry is more, it's all about how many of something you have. That's not realistic for real chemistry. We can't go in there and count how many moles something is. So what we do is we can count by weighing. Okay, and remember the count is what we needed for stoic. I can't emphasize this enough. It's the number of particles that we need for stoichiometry, not really how heavy it is. But we can't find that number without weighing it. Okay? So to give answers in grams, because useful. Okay, so for example, what do I mean? How much oxygen can you make from the breakdown of 18 grams of water? Okay, so this would be a stoichiometry type problem. Maybe a chemist might want to answer. Right? And the answer, which you're going to learn how to do later, is 0.5 moles. Okay, so the problem with that answer is it is not useful. Okay, so this answer, not useful in real life. Because we cannot measure this with an instrument. Okay, what will be more useful is, how heavy is it, or how much volume does it occupy? Okay, so if you had 18 grams of water, how much oxygen can you produce from it? Now this too is how many of these particles you have, not how heavy it is. So what you'd first have to do is figure out, well, how many particles is 18 grams? And then I could use this. And if I could figure out how many particles 18 grams of water is, I would find out that, hey, that's 1 mole. Okay, I'll just take my word for it right now. You'll learn how to do that later. So that's 1 mole. So how much water can I make from it? Well, it's a 1-to-2 ratio, right? This is half of that. So then I make 0.5 moles of this stuff. Okay, and that's what I put here, 0.5 moles. Oh, geez, I forgot to do this. Okay, 0.5 moles. And that's not useful. That's not useful. You can't go out and say, okay, get me 0.5 moles, a container that can hold 0.5 moles. You don't even know what that is. So you'd have to know how to convert 0.5 moles of oxygen into, you know, a mass. So you know, like, how much would that weigh? It gives you an idea of what it would look like, or the volume since it's a gas, right? So remember, mass, we use mass in stoichiometry because we can measure it, okay? And the unit would be in grams for chemistry. But what we absolutely need for stoichiometry is moles, because that is what the balanced equation can use. The ratios in the balanced equations are all about the ratio of the moles. Alrighty? Alright, so that was review, kind of like I sprinkled in there some concepts about stoichiometry, but we should already know basically what a mole is. It's a counter, and we've had it before. And we should already know what mass is, how heavy something is, and we measure that in grams. Alrighty, so bear with me. I am still working. I'm a novice at all this. Write your notes down, and then the next video will be about molar mass.